Welcome back again, ladies and gentlemen. It's time for more awesome trig partying here with the other part of the other trig function graphing. We're going to do secant, cosecant here. Okay, so secant and cosecant are a little weird. Remember how it's reciprocals, right? Okay. So when the sine is equal to 0, let me underline this here. When the sine is equal to 0, the cosecant is what? Well, the reciprocal of that would be undefined, right? Okie dokie. And what will happen? There will be an asymptote. We saw this with tangent and cotangent, right? Same thing, when the cosine is equal to 0, that's a 0, folks. That's an R. The secant is undefined, and there will be an asymptote on the graph. So what I want to do to first showcase these graphs is I'm going to start out graphing cosine, and then I'm going to show you how to get secant from that graph. So I'm going to pause it here right now and go ahead and graph the regular cosine function. In fact, I think I will do cosine in red. Okay, so I'm going to pause it. All right, there are my key points, and I'm going to sketch my curve. Remember, this is cosine. This is not yet secant. I'm showing you where it comes from. Okay, so at this time what I'm going to do is I'm going to change colors. Let's do blue. Why not? Blue's cool, right? And I'm going to graph secant. Remember, everywhere cosine is 0, secant is undefined. So everywhere I'm on the x-axis for cosine, I can draw an asymptote in for secant. Everywhere I'm on the x-axis, I can't divide by 0, right? So all of these values will now be places for an asymptote. And then the rest of it is really cool. It just kind of flips over. So the top, the maximum point, now becomes a minimum point. And where it used to kind of hump up like a hill, if you will, curves more like a valley. And what used to be a minimum now becomes a maximum point, and it curves away. Neat, right? So if you really think about it, that red line, that red graph, that cosine graph, is not supposed to be there. I simply did it so that you could see the graph being generated. So what's the domain for secant? Let's change colors again. The domain. Well, same problem, right? It's asymptotic. We can't have all real numbers. It is kind of all real numbers, except for those bad x's. Except where are the bad x's? Well, the bad x's again are appearing at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2. So, except for where x is pi over 2, I'm going to run out of room here, plus n pi, where n is an integer. Okay. Range. Now this time it gets weird. It's not all real numbers, and it's not just from -1 to 1. In fact, from -1 to 1 is kind of where the non-range is. Think about it. It bounces up at 1. So it's 1, 2, 3, 4, 5, 6 all the way up. And then from -1 it goes down, -1, -2, -3 all the way over. So to write the range in interval notation, and again, you might not know interval notation. We will definitely get to it in this course. Negative infinity to -1, union 1 to infinity. Oops, hold on, that looks too rigid. That's supposed to be a parenthesis. My finger failed. There we go, that looks a lot better. Cool. Period. What's the period? Well, you have to think about this as how long does it take for the cycle to repeat? It's 2 pi, because I have this piece right here that's an up little hump, and then I have this piece over here which is a down little hump. It doesn't start to repeat until right here. So from right here, this asymptote, to right here, this asymptote. That is a full 2 pi units. Period remains the same as the base cosine function. I was going to skip through this, but I think I kind of want to run through it real quick. I'll look at, it doesn't really matter, number 1 or number 2. I'll do number 1 because it's at the top. Amplitude, again, guys, we don't really have any true amplitude with these graphs. You don't have to worry about it. Is there a reflection here? No, there's no negative in the front, so I don't need to worry about doing a reflection. What's the period? Period is still like 2 pi over b. Here b is 1, so my period is 2 pi. Important values. Again, it's going to happen where you take the period divided by 4. So when you take 2 pi and divide it by 4, you do still get pi over 2. So every pi over 2, we're going to have to look at an important value. Phase shift, is this guy shifting? No, there's nothing going on inside with x. But there is a vertical shift, right? It's being shifted up 1 unit. Okay, cool. So let's see here. What do I have? Ooh, the first thing I can do is draw in my asymptotes, right? Because I know that there are asymptotes here. I'll draw those in red. Where do my asymptotes occur with secant? Well, it's all of the places where cosine is typically 0. Where is cosine typically 0? Well, right here at pi over 2. And then again at 3 pi over 2, so let me count over. There's pi, there's 3 pi over 2. We can go over to negative 3 pi over 2. There's an asymptote right there. And then there's one right there. Cool. Okay. I have that. Let's see. What's next? Oh, I can go ahead and start plotting my important values, right? Okay. So what happens at 0? Well, normally at 0, it's where? Well, let's go back for a second and think about this. Normally, what would we do? We would have our cosine midline right here. Our cosine maximum would be up at 1 and down at -1 for the minimum. And so that 1 and that -1 would still be what I'm looking for with my secant function. Sorry, I forgot my train of thought there. But this whole entire thing has been shifted up 1. So this midline, if you will, is no longer at the x-axis. It's been moved up 1 entire unit. So I need to think in reference of this line now. I no longer need to think about the x-axis as being where I go up and down from and plot my little points and draw my curves and everything. The entire function has been shifted up 1 unit. Okay, so now I can graph my function. I know that it should be here and go up like that. See that? I know that it should be right here. That's pi, by the way, that's pi. And going down. See, there's pi over 2 right there. There's pi, there's 3 pi over 2. There's 0, there's negative pi over 2. There's negative pi, okay. So at negative pi, I have another maximum value right there. And then, woo, that's pretty bad. And then I'd have another one right here if I was going to draw that piece in like that. Because remember, if you need to, you can always graph that cosine function to help you do this. There's no harm in that. There's no shame in it at all. What happened to cosine here? What do we do with it? We shifted it up 1. and then it had, let's see, I forgot what I was doing again. Oh, right, okay, sorry. I'm just all over the place. Here, I would have a dot right there. I would have a dot on the asymptote. It would be here, it would be here, it would be here. So here is the cosine, here, here. I'm one of those people that unfortunately doesn't sketch very well unless I have those dots on my paper. That's why I hesitated there for a second. I was like, hold on, I got to draw it in. I can't talk about it. I need to see it. So that right there is the cosine function that I'm, getting this other function from, if you will. So if you need to kind of jot that in to check it, that's great. I'd really rather have you leave it off because it is technically not part of the secant graph. So I'm going to kind of go back through here with my eraser that doesn't work very well and take that off. There we go. Cool. Cosecant. Here we go. So again, you can think of this as the reciprocal of sine. So you can start out and graph all of those important values for sine. You've got one right there, and then we go up to the top, then we're back down right there, and then we are at the bottom, and we are back here. 3 over is down there. Another 3, we're back up. Another 3, we're up top. 3, we're back down. So there is my sine function. Okay, there's sine. Now remember, what used to be a 0 for sine is now an asymptote for cosecant. So I can also go ahead and draw those pieces in. Here is an x-intercept for sine, so there's an asymptote. There's an asymptote. There's an asymptote. Let me draw that asymptote a little bit clearer there. There we go. There's an asymptote. There's a terrible looking asymptote. I was way off on that one. Okay, so now I can go ahead and sine is in dotted red. I can go ahead and draw my cosecant in blue. Remember, what used to be a max is now a min. Curve it up. What used to be a min is now a max. Curve it down. That's it. That's how you do your sketch for cosecant. Domain. What's my domain? Well, again, can't say all reals because we have these asymptotes everywhere. But it is the set of all reals, except for which values of x. Where are the asymptotes located? At 0 pi, at 1 pi, at 2 pi, at 3 pi, at negative 1 pi, at negative 2 pi, at negative 3 pi. So the asymptotes are located at every pi n, again, where n is an integer. You really should be writing that where n is an integer each time. I just don't have room on my crappy little notes here. Range, same exact range as secant. Everything down under all the way up until -1, starting again at +1 all the way up to infinity. So the range runs from -infinity to -1 union 1 to infinity. Okay, period. Just like before, it is 2 pi. Okay guys, thanks for watching. I know it's kind of a long, drawn-out, arduous process here, but we need to make sure that we can get some good quality sketches by hand.